Hi dears, I hope you have worked out the questions yesterday. Can you view the screen? If not, let me know so that I can adjust the stand. So we were working exercise 7.4. So till question number 10 we have worked out yesterday. Hi Chitra, good afternoon. Hi Murli, good afternoon. Hi Nikila. Hi Nandini. Hi Suresh. Hi Pavan. Hi Aishwarya. Hi. Hi Bharani. Hi Ramya. Hi Avantika. Hello, good afternoon. Hi Satish. Oh, it is clear. Okay. Thank you. So many, I couldn't even read the names. Like the chat box is running like anything. And thank you. Nearly 85 have joined. Wow. So I guess it is convenient, right? This time. Anyway, from next week we'll be having the school. So we can have it in the early morning or in the night. Text me or like put a message in the comment box your convenient timing so that I can have the classes, schedule the classes accordingly. Hello Chandani. Hello Niharika. Hello Subiksha. Hello Raji. Hi. Thank you. Can we move on to question number 11? Today, the interactions are more than I expected. Thank you. And nearly 100 have joined. So happy that these many have joined. Thank you, dear students. Because from past week only, last week only I started the live classes. So far I have just uploaded the shorts and videos, and I also asked in poll that how many are okay with the live classes or not. Since I started from last week, this many strength in the beginning itself I didn't expect, and I didn't expect that many will join at this time. And if it is convenient, let me know it is okay, or if you want to change the timings, I'm ready to reschedule. And thank you for your support. Nearly 120 of you have joined now. That itself a big success for me, as so many are interested to learn. Some might be teachers or some might be the seniors who want to teach the sisters, siblings. Many can be here. So I heartily welcome you all. Thank you for your support. So I'm just doing these all things because of your support. Thank you so much. So we'll move on to the questions. Question number 11. If you cannot understand, let me know. I can reteach that. So question is given 1 by 9x square plus 6x plus 5 dx. Again a quadratic equation. But if you see, like numerator we have only 1. So it is easy for us to simplify only the denominator part. So starting with the equation, like previous question how you did, the same way. The question number 10 is just the sample for these questions. Just write, consider 9x square plus 6x plus 5. What is the first step? We need to check the coefficient of x square as plus 1. And what is the coefficient we have here? 9. So the step will be you need to take whatever the number is there, you need to take that as common. So since we have 9, I have taken it as common. So 9 x square plus 6 by 9x plus 5 by 9. As we have taken 9 as common and these two terms We don't have 9 as like no the common term. And now that will become, since we can simplify here, so this will become 3 2s are 6, 3 3s are 9. Yeah, so 9 into x square plus 2 by 3x plus 5 by 9. And the next step will be, we need to take the coefficient of x, that is 2 by 3 divided by 2. Since it is fraction, I am writing it as into 1 by 2. Okay, so now 2 gets cancelled, you will get it as 1 by 3. And square of 1 by 3 is 1 by 9. Either you can write it as 1 by 3 square or 1 by 9. Both means the same. So 9 into x square plus 2 by 3. So first write these two terms, then plus the square term of the number what you have divided by 2. So that is 1 by 3 square. Then write the number what you have here minus 1 by 3 square. So we need to add and subtract the number what you get after dividing by 2 the coefficient of x, that you have to add here. Okay, add and subtract. And we need to combine these three as one term, these two as a separate term. And you need to check which format it looks like. So it is in the form a square plus 2ab plus b square. In place of a you have x, in place of b you have 1 by 3. Okay, so 9 into x plus 1 by 3 the whole square, and here you have 5 by 9 minus 1 by 9. So it is easy for us to simplify as denominators are same. So that will be 4 by 9, and that can be written as 1 by 3 the whole square. Since greater number is plus, you will be writing 4 by 9. We can also write it as 2 by 3 the whole square. Now the question becomes I equal to this 9 I am taking out. It is in the denominator part. So 1 by 9 integral dx by, we got it as x plus 1 by 3 the whole square plus 2 by 3 the whole square. In place of x you have x plus 1 by 3. In place of a you have 2 by 3. So now we have the formula integral dx by x square plus a square equal to 1 by a tan inverse x by a plus c. So this is your formula. So 1 by 9 we have already out, and 1 by a, that is 1 by 2 by 3, that can be written as 3 by 2 tan inverse, in place of x it is x plus 1 by 3 by 2 by 3 plus c. And now we can simplify this 3 and 9 as it gets cancelled. So it is 1 by 3 2s are 6 tan inverse. When we take the LCM, it will become 3x plus 1 by 3, and 2 by 3 reciprocal will be 3 by 2 plus c, and 3 gets cancelled. So you get 1 by 6 tan inverse 3x plus 1 by 2 plus c. This is the required answer. Any doubt in this? Yes, Chandrika, you have to simplify, because quadratic equation cannot be simplified as you were doing the previous exercise. That cannot be simplified. So we are using completing the square method, so that we can express as x square plus a square, or x square minus a square, or a square minus x square form, and use the formula appropriately. Substitute in place of x whatever you have, and in place of a whatever you have. Okay, is it clear? Yes. Hello Akshaya. Yeah, the formulas that I have uploaded as a short, and I showed you the formulas in yesterday's live class. Those 6 formulas plus the trigonometric and the integrations that we have learnt in the beginning of the chapter, those everything you have to be thorough to do this exercise with the new methods also. Okay, Can we move on to the next question? Yes, Chandru, you have to do by completing the square method. Or if you are using by other methods, you can factorize that. Quadratic formula is to find the zeros or the roots. Here we need as x square and a square form. That's why we are using this. Okay. Any other doubt? So moving on to question number 12. If you cannot see, please put a message. So question number 12. I equal to 1 by root of 7 minus 6x minus x square dx. It is like the same previous question, but we have root here, and also we need to take care of the completing square method, that is consider. Yes, Rahul, like instead of writing each step as integral 1 by root of like those steps, you can write consider and writing this 7 minus 6. Like you are mentioning that you are considering this term and solving or simplifying that particular part, and you are substituting in the question. That you can do. Okay, but you need to mention whatever you are doing. So, yeah. Okay. The first step we need to check. Very good, Adirai. Very good, very good. First step, we need to check whether the coefficient of x square is plus 1. And what we have here? Minus 1. So take that minus as common. So now this will become plus. Same way, we'll try to rearrange in decreasing order. And as we have taken minus as common, this negative terms will become positive and positive term will become negative. So we have checked for the coefficient of x square as well as we have rearranged the term in decreasing order of their degrees. Okay. Next. What will be the next step? Very good, Hari. Very good. We have to divide the coefficient of x term by 2. So we will be getting it as 3. So it will be x square plus 6x plus 3 square. Write this number as it is. Then minus 3 square. So that you will not get confused with the negative and positive sign. Now minus 1 into combining these two. This is of the form a square plus 2ab plus b square. So that can be written as a plus b the whole square. So x plus 3 the whole square. Minus 7 minus 9. Both are negative. So that can be written as minus 16. Now multiply this minus inside. As we have formulas for all the categories, we don't even worry about the signs of the terms x and a. Okay. Multiply the minus inside. Now this become plus, this become minus. And 16 we can write it as plus 4 square. And this will become x plus 3 the whole square. I'm just writing the equation part alone, and I have simplified using the completing square method, and we have simplified as 4 square minus x plus 3 the whole square. Now the question will be 1 by root of, in place of that equation we have simplified as 4 square minus x plus 3 the whole square dx. As now we can see it is of the form 1 by root of a square minus x square. And what is the formula? Can anyone mention here? Very good, Nandini. Very good, very good. So it is of the form a square minus x square. So it is sine inverse of x by a plus c. Very good, Nandini. Keep it up. So now this will be integral. Sorry, we don't get that one. So sine inverse of, in place of x you have x plus 3, by in place of a you have 4 plus c. This is the required answer. Any doubt in this? Any doubt? So question number 13. I equal to integral 1 by root of x minus 1 into x minus 2 dx. Here also we have to do the same thing. So what we have to do? What we have to write? Consider. In previous question we had it as an equation. Here they have given as factors. So we need to multiply. So that will be x square minus 2x minus x will be minus 3x plus 2. So the first step is to check the coefficient of x square. Here we have positive 1. The next step is to divide the x term by 2. So you will be getting it as 3 by 2. So x square minus 3x plus we got it as 3 by 2, isn't it? 3 by 2 the whole square. Then write as it is the constant term. Then minus 3 by 2 the whole square. Is that clear? Okay. Now, these three terms when we combine it is of the form a square minus 2ab plus b square. In place of a it is x, in place of b it is 3 by 2. So that can be written as x minus 3 by 2 the whole square. And now we have 2 minus 9 by 4. So we need to take LCM in this step. That becomes, so x minus 3 by 2 the whole square. When we take the LCM in this step, that will be plus 8 minus 9. So plus 8 minus 9 will be minus 1 by 4. That we can write it as x minus 3 by 2 the whole square minus 1 by 2 the whole square. Okay. The question now becomes I equal to 1 by root of x minus 3 by 2 the whole square minus 1 by 2 the whole square into dx. Now we need to check in which form it is and we have to use the formula accordingly. So here it is of the form dx by root of x square minus a square. And what is the formula we can use here? Very good. Log of x plus root of x square minus a square plus c. So this is the formula you can use. In place of x you have x minus 3 by 2. In place of a you have 1 by 2. So this can be written as log of x minus 3 by 2 plus, you can write it as x minus 3 by 2 the whole square minus 1 by 2 the whole square, or you can write it as log of x minus 3 by 2 plus, in place of x minus 3 by 2 the whole square minus 1 by 2 the whole square, you can write it as x square minus 3x plus 2 or x minus 1 into x minus 2, because that is what we have simplified, right? So you can write like this or the equation. Both means the same. Okay. This will be the final answer. Any doubt? Can we move on to the next question? So question number 14. Integral 1 by root of 8 plus 3x minus x square dx. It is very similar to the 12th question. Okay. As usual, what we have to write? Consider 8 plus 3x minus x square. Here we need to rearrange in decreasing order of the degrees, as well as we need to check the coefficient of x square. Here it is minus 1. So we can take minus 1 as common. So this will become x square minus 3x, because both the terms are positive. When we take negative as common, these two will become negative. And now the same thing like previous question, we have 3 here. So we need to add and subtract 3 by 2 the whole square. So plus 3 by 2 the whole square minus 8 minus 3 by 2 the whole square. Combining these three, it is of the form a square minus 2ab plus b square. So x minus 3 by 2 the whole square. Here you have minus 8 minus 9 by 4. You will be taking the LCM. So when we take the LCM, you will get it as minus 32 minus 9. So it will be minus 41. And multiply the minus sign inside. That will become, this will become positive, isn't it? And this will become negative. And 41 is not a perfect square. We can write it as root 41. And 4 we can write as 2 the whole square. So root 41 by 2 the whole square minus x minus 3 by 2 the whole square. So here the question becomes I equal to integral 1 by root of, can you see? Root 41 by 2 the whole square minus x minus 3 by 2 the whole square dx. Okay, we need to write which formula it is. So integral dx by root of a square minus x square can be written as sine inverse of x by a plus c. And in place of x you have x minus 3 by 2, a you have root 41 by 2. So I will be sine inverse of x minus 3 by 2 the whole by root 41 by 2 plus c. So when we take the LCM, it will become sine inverse of 2x minus 3 by 2 into 2 by root 41 plus c. So 2 gets cancelled. The final answer will be sine inverse of 2x minus 3 by root 41 plus c. This will be the final answer. And I want you to try question number 15. I want you to try the question number 15 by yourself. And if you have any doubt, post it in the comment section. It is very similar to the question number 13. In question number 15, you have x minus a into x minus b. Here you have x minus 1 into x minus 2. It is very similar. So I just want you all to try. Moving on to question number 16. I equal to integral 4x plus 1 by root of 2x square plus x minus 3 dx. Here we have a numerator part. Previous questions we just had 1. So it is easy for us to substitute. Like we have used completing the square method and we have used the appropriate formula and we have simplified using that and written the final answer. But here you have a numerator part. Okay, let us try to take a denominator. So let 2x square plus x minus 3 as t. If suppose if you are getting the derivative as numerator part, we can use the substitution method. So that will become 4x plus 1 equal to dt by dx when you differentiate on both sides. And that is what we have it in the numerator. So cross multiply the dx term. So we'll have 4x plus 1 into dx equal to dt. So I can be written as integral dt by root t, or that can be written as t power minus half dt. And using the power formula, like power rule, minus half plus 1 will be half. So it is 2 root t plus c, because in denominator you have 1 by 2. When we take the reciprocal, it will be 2. And replacing t in terms of x, so it is 2x square plus x minus 3 plus c. So this is just using the substitution method. Is that clear? Question number 17. Integral x plus 2 by root of x square minus 1 dx. What can be done? So it is easy for us to split the terms. Let's see whether we can get the answer. So x by root of x square minus 1 dx plus 2 into integral dx by root of x square minus 1. Here you can use the formula. Sorry. Here you can use the formula and directly, and here you have to use the substitution method. Let us take it as I1 and I2. Let this be the first equation. So for I1, let us use the substitution method. So let x square minus 1 equal to t. When we differentiate, you will get as 2x equal to dt by dx. Only x into dx we have in the numerator part. So this will become dt by 2. So I1 will become dt by 2. That 1 by 2 I have taken out. So dt by root t. The same procedure what we did here. So we got it as 2 root t, isn't it? And already we have 1 by 2. So plus c1 we can write. 2 will get cancelled. So in place of t it can be written as x square minus 1 plus c 1. Okay. The next is I2. I2 is integral dx by root of x square minus 1. Okay, and here you can use the formula. What is the formula? Integral dx by root of x square minus a square, that can be written as log of x plus root of x square minus a square plus c. This is the formula you can use here. In place of x we have x, in place of a we have 1. This can be written as log of x plus root of x square minus 1 plus c2. And now when you substitute in the first equation, it will be I equal to I1 answer is root of x square minus 1 plus c1 plus 2 into log x plus root of x square minus 1 plus c2. Okay, and now you have it as root of x square minus 1 plus multiply 2 inside log of x plus root of x square minus 1 plus c1 plus 2c2, because when you multiply 2 inside we will get it as 2c2, and replacing these two terms as capital C. So final answer will be x square minus 1 plus 2 log x plus root of x square minus 1 plus capital C, where C1 C1 plus 2c2 is written as C. Sorry for the interruption in between. Next, question number 18. I equal to integral 5x minus 2 by 1 plus 2x plus 3x square. So if you see, when we take the denominator as t like the previous question, you can't simplify, or you will not get the derivative, isn't it? So what can be done? Just a minute, just think, I'll come. Sorry for the interruption in between. Okay, and here, how to solve this question? In the previous question, if you check, we had used the substitution method, and here you can't use the substitution method because of the terms. When we take the denominator as t, I can take it as t. When we differentiate, I get it as 6x plus 2, whereas I have a different term in the numerator. So substitution part cannot be done here. So in which method we can do? So we have a new method here to solve, that is, we are rewriting or rearranging the numerator as, write whatever the numerator term you have. This method is applicable only when you cannot use the substitution method, or that means directly, or any other formulas. Then only this method can be applicable. So 5x minus 2, we are rewriting this numerator as a. So already you would have learned partial fractions in the lower classes, isn't it? So here a into derivative of the denominator plus b. So we are rewriting the numerator as a into derivative of the denominator plus b. This is the procedure when you can't use the substitution method directly, or when you cannot apply the trigonometric properties or identities, algebraic properties or identities, or the completing the square method. If you do here, we have numerator, we don't have 1 here. So completing the square method can be done only when the numerator is 1, or else you can't use the formulas, as all the 6 formulas whatever we have learned before this exercise involves the denominator as 1, not any other term. So you can't use those 6 formulas here directly. You can't use trigonometric or algebraic identities or properties here. You can't use the substitution method directly. In that case, you can write the numerator as a into derivative of denominator plus b. Okay. Now that will become, the derivative of denominator is 6x plus 2 and plus b. Now we need to find the a and b value. Let this be the first equation. We need to find a and b value. Before that, we will just multiply inside. So 5x minus 2 equal to 6ax plus 2a plus b. If you see, we have only one x term and we have constants. Okay, we are just using the partial fractions that you have learned in the lower classes. The same thing. And I want to make this as 0. Okay, so let x is equal to 0. So this side it will become minus 2. This will become 0. I will get it as 2a plus b. Okay. This will be your second equation. Now, let x is equal to 1 by 6. So what we get? Or you can equate the x terms, constant terms also. So when we substitute x as 1 by 6, I'll get it as 5 by 6 minus 2. And here 6 in and 1 by 6 gets cancelled, plus 2a plus b. So when we simplify, we'll get it as minus 2 by 6 as 5 minus 7 equal to 6 and 6 get cancelled. We'll get it as a, already have 2a, so that will become 3a plus b. So this will be your third equation. Now solving 2 and 3 by substitution, elimination, or whatever form you can do. Okay, so we can subtract 2 and 3, so that minus 2 minus of minus 7 by 6 equal to 2a plus b minus 3a minus b. I am just subtracting the terms. Plus and minus gets cancelled. Here it will become plus 7 by 6 equal to 2a minus 3a will be minus a. So when we take the LCM, it will be minus 12 plus 7. So So it will be minus 5 by 6 equal to minus a. A minus minus gets cancelled. So a's value is 5 by 6. Is it clear? Is it clear? So a value is 5 by 6. Okay. And b you can substitute in any of the equation. Let's substitute in second equation. Substitute a in second equation. So that will be minus 2 equal to 2 into 5 by 6 plus b. 2 and 6 you can cancel and take this plus 5 by 3 to the left side. So that will be minus 5 by 3. And when we take, so equal to b. When we take the LCM, it will be minus 6 minus 5. It is minus 11 by 3. So it is minus 11 by 3. B value is minus 11 by 3. A value is 5 by 6. That you have to substitute in the first equation. That will become, so first equation becomes 5x minus 2 equal to, a value we found it as 5 by 6 into 6x plus 2 plus b value we have found it as minus 11 by 3. So plus into minus, minus 11 by 3. Now the question becomes, in place of 5x minus 2, that can be written as 5 by 6 into 6x plus 2 minus 11 by 3, the whole by, I'm just rearranging the terms, 3x square plus 2x plus 1 dx. Okay, here we are replacing 5x minus 2 as the value whatever we get for a and b and substituting in the given question. Any doubt in this? And now you can split the terms into 2. So 5 by 6 integral 6x plus 2 by 3x square plus 2x plus 1 dx minus 11 by 3 integral dx by 3x square plus 2x plus 1. And now we can take it as, so I equal to 5 by 6 I1 minus 11 by 3 I2. This will be your, what equation? 2, 3 we have used. This will be your fourth equation. And now I1 value is integral 6x plus 2 by 3x square plus 2x plus 1. If you check here, if I take the denominator as t, when I differentiate it, it will be 6x plus 2. So I will be getting the numerator part. So let 3x square plus 2x plus 1 equal to t. When we differentiate both sides with respect to x, we get it as 6x plus 2 into, I'm just taking dx straight away here. So in place of 6x plus 2 dx, that can be replaced as dt by t. So the integration is log t plus c1. So now log of t is 3x square plus 2x plus 1 plus c1. Okay. Now the second integral, that you have to use the completing the square method. I2 is integral dx by 3x square plus 2x plus 1. So now 3x square plus 2x plus 1. So I'm just considering that alone, completing the square method. So the first step is the coefficient of x square should not be any other term other than 1. So I'm taking that as common and dividing the x term by 2. So you'll get it as 2 by 3 into 1 by 2. 2 gets cancelled. So you'll get it as 1 by 3. And here also 1 by 3. So 3 into x square plus 2 by 3x plus 1 by 3 square plus 1 by 3 minus 1 by 3 square. And combining these three terms, it is of the form a square plus 2ab plus b square. So 3 into x plus 1 by 3 the whole square plus 1 by 3 minus 1 by 9. Taking the LCM, we get it as 3 into x plus 1 by 3 the whole square. So 9 will be the LCM. So here it will be 3. 3 minus 1, it will be 2. And I am writing it as root 2 by 3 the whole square. Okay. The question now will become, Integral dx by 3, I'm just taking it out, x plus 1 by 3 the whole square plus root 2 by 3 the whole square. Now it is of the form integral dx by x square plus a square. And what is the formula? 1 by a tan inverse of x by a plus c. Okay, that is the formula we can use here. And this will be already 1 by 3 we have out. Tan inverse of, in place of x you have x plus 1 by 3. In place of a you have 2 by 3. So when you take the LCM, 3 gets cancelled. So 1 by 3 tan inverse of 3x plus 1 by root 2 plus C2. So this is the I2's answer. Now the fourth equation will now become, and plus C1 plus C2 we can write it as capital C together. Like you can combine that and you can write it as 1. So 5 by 6, so I equal to 5 by 6 log 3x square plus 2x plus 1 minus 11 by 3, and already 1 by 3 we have. So 11 by 9 tan inverse 3x plus 1 by root 2 plus capital C, where capital C is, we have 11 by 9, isn't it? So 5 by 6 C1 minus 11 by 9 C2, we have taken it as capital C. That you need to mention. Is it clear? Any doubt? Okay. So in the next live class, we will move on to exercise 7.5 with the partial fractions, and the remaining questions I'll give you as a worksheet. So complete that, and if you have any doubt, post it in the comment section. Okay. Thank you for your support. I didn't expect that these many students will join, and many of you very interactive during the class. Thank you for that. In between, when I couldn't concentrate on the messages, whatever you have sent. Whatever the queries, posted in the comment section. I will try to rectify as early as possible. And thank you so much for your support. As many, nearly 125 have joined in the class. And thank you for the support. In the next live class, we will discuss exercise 7.5. Thank you. And before the next class, complete the worksheet, whatever I have uploaded. So I'll be uploading it as short, so that it will be convenient for you to refer whenever you need. Okay. Thank you, my dear students.